Properties of similar triangles. For example number 1, we're going to take a look at the diagram to the right. So we have two triangles, QRS and STU. So we have to think about the order that these triangles are labeled. So it goes QRS, which is similar to UTS. So the Q and the U are those common angles. So whatever order they go in would be the order that the angles are going to be common. And sometimes it's helpful if you can just imagine rotating this smaller triangle so that it's orientated the same as this larger triangle. So keep that in mind. For part A, it wants us to find the angle that is equal to angle RQS. So remember that's the same as angle Q. So as I mentioned before, here's angle Q. And angle Q would be similar or equal to angle U, because those come in the order that they're listed in. So angle Q is the same as angle U. And I can just label it as angle U like that, or I could label it as angle, instead of going RQS, I could go TUS. But angle U is perfectly fine. So it's important to know the different variations, though, how it's written, because when we get to the angles that are they're labeled the same letter, depending on the diagram, it can get kind of confusing. So now we want to know the angle that's equal to angle TSU, which is angle S, but angle S is in this triangle, the small one, and it's in the big triangle. So this angle TSU refers to the small angle right here, where we want to figure out, we know that this small angle is going to be the same as this angle across from it because of that X pattern. So we know that these are opposite angles. So anytime two lines intersect, the angles across from each other are going to be exactly the same. That's one of our angle property theorems that we know. So we know that this angle S needs to be the same as this angle S. And I could call it angle S, but because they're written the same, we have an angle S and in the small one and the big one, you might want to label it using the 3 letters. So instead of going TSU, I'm going to call this one RSQ. So you'll notice that I go in the same order that this angle was in the first one. So I went from the right angle to S to that one. So I'm going from the right angle to S to Q for the other one. Now I want to figure out what side corresponds to QR. So remember QR, I can either label it as the vertices that make up that line, or I can call it from S because that's the angle that's across from it. But again, remember that even though this is S in the big triangle, this is also S in the small triangle. And so it can be kind of confusing when they're called the same letter. So instead of saying S corresponds to S, so these two sides are in proportion to each other, we're going to say that QR is in proportion to UT. Or if you really wanted to, you could call it S. Okay, either of those would be fine. And then in part D, we want to know the side that corresponds to SU. So that's the hypotenuse right there. So this would be labeled T in the small triangle, and it would be labeled R in the big triangle. So we could call it R, or we could call it the letters that make up that line segment, which would be SQ. So know that there are multiple ways to represent those angles and sides. Now let's take a look at these other two similar triangles, for example, 2. So I have triangle KLM is similar to triangle NPO. So N and K are the same, and P and L are the same, and O and M are the same. So whatever order they are in written is also the order that they match up to geometrically or visually. So I want to know what side, or what is the measurement of side PN. And PN is also side O, or in our case, it has the variable B in this example. So I want to find out what this measurement is. And because these triangles are similar, so it's given to me that they're similar, I don't have to prove anything, then what I want to do is I want to come up with some ratios that will work to find out this unknown value. So I'm going to start by labeling the sides of my larger triangle. So across from K is K, across from L is L, and across from M is M. I'm going to do the same thing for my small triangle. Across from N is N, across from P is P, and across from O we already said was O. And now I want to set up what sides are going to be in proportion to each other. Well, I know that my hypotenuses have to be in proportion to each other. So 12 is in proportion to 6. I know that my height needs to be in proportion to each other. So M has to be in proportion to O. And I know that the bases have to be in proportion to each other. So K is in proportion to N. And I can, instead of subbing in the numbers right away, I could have also done L over P as well. So now that I've just listed the letters, I can now plug in the numbers that I know. So I know that L is 12, P is 6, M is 11, O is still O. I'm not quite sure what that is. Or I can call it B, because that's the letter that's given to me in my example. And I don't know K, and I also don't know N. So I have to solve for B in this case, which is the side length PN. So I'm going to use these two ratios. And I'm going to use those ratios to solve for my letter B in this case, or O. It doesn't matter which one you use. So I'm going to do my cross multiplication. So 12 times B is equal to 11 times 6. 12 times B is equal to 66. Now I'm going to divide by 12 from both sides. So it crosses out on the left-hand side. And B is equal to, when I work this out in my calculator, I get 5.5. And my units, so what am I measuring these side lengths in, is centimeters. So my answer to part A would be 5.5 centimeters. Now I want to take a look at finding some missing angle measurements. So I want to find angle PNO. So that's really angle N. So remember the letter in the middle is the one that you're finding. So this is N here, but N is also the same as K because those two angles are in the same position. So this angle PNO is equal to 25 degrees. Now I'm going to take a look at finding angle KML. So remember that's the same as finding angle M, which is right here. Now angle M would be in proportion to angle O, but I don't know that one either. But I do know two angles in this large triangle. And I know that the angles in a triangle add up to 180. So if I subtract 25 and 90 from 180, that'll give me this missing measurement there. So this is the interior angle of a triangle theorem. So all of the angles in a triangle add up to 180. So I can take M is equal to 180 minus 25 plus 90 is 115. And 180 take away 115 is 65 degrees. So angle KML or angle M is equal to 65 degrees. So what is angle O? Well, I've already established that angle M and O are going to be exactly the same, so O will also be 65 degrees. So it's important that you include your measurements for your side lengths and the degree symbols for the angles in your final answers. Number 3, why are these triangles similar? So I have two triangles, DEF and GHI. So you'll notice that when I was calling out the triangles, I called them out in the same order that the angle symbols appeared. So I went DEF, and I start with the star on the other one, GHI. So that's something to think about. So I need to do my 5-line proof for this one. So I need to have my introductory statement. I have to find 3 reasons why these triangles are similar, and then my conclusion. So let's start by introducing the triangles. So I have triangle DEF and triangle GHI. All right, so what do I know from these triangles? Well, I know that angle D is equal to angle G. That's given to me. So angle D is equal to angle G. That's just given. I also know that angle E is equal to angle H. That's also given. And I also talked about this in that previous example. So I know that the angles inside of a triangle add up to 180 degrees. So this angle F right here would be 180 subtract star plus check mark. But this angle I would also be 180 subtract star plus check mark. And these are exactly the same. So because the 3 angles in the triangle add up to 180 degrees, if 2 of them are the same, then by default, the last one will also be the same because of that interior angle of a triangle theorem. So we know that angle F will also equal angle I because of interior angles. And I'm fine if you just put interior angles. Some teachers want interior angles of a triangle theorem. Some people will take ITT, which is the short form for interior angles of a triangle theorem. That's as long as it's clear why those are the case, then I'm fine, okay? So then I've given my 3 points about why they're similar, so now I can write my concluding statement. So therefore, triangle DEF is similar to triangle GHI because of angle, angle, angle. So those are the 3 properties that I found to be true. Let's do a couple more examples. Example number 4 is another proof. So we want to prove that these triangles are similar. We want to show any calculations that we're going to use, and we're going to write that similarity statement. So the first thing I want to do is introduce my triangles. So I have triangle, I'm going to go triangle PQR. And I have to think about what the orientation will be for my other triangle. So I did PQR. So I did the top of my triangle, in this case is going to be A, and I went to the smaller side first and then to my base. So instead of going AC, I'm going to go AB because that's the smaller side. So A, B, C. All right, so I've introduced my triangles. Now I want to come up with why they're going to be the same. I don't know anything about the angles, so I'm not going to be able to use that one. And because I don't know anything in the angles, I'm not going to be able to use, so remember the ways that we can show triangles are similar is showing that all 3 angles are the same, all 3 sides are the same, or 2 sides and the angle in between are the same. So because I don't know anything about these angles, I can't use the first one and I can't use the last one. So I have to show that it's similar by side, side, side. So I have to show that these sides are in proportion to each other, or they have the same ratio. So one triangle is a scale factor of another triangle. So I'm going to start by labeling my sides. Across from A is little a, across from B is little b, across from C is little c. Across from P is little p, Q is little q, and R is little r. So what do I know? Well, I know that A has to be in proportion to angle or side P in this case. So let's see what that is. So A over P. Well, A is 20 and P is 5 and 20 divided by 5 is 4. All right. So my goal is to show that the other two sides, when I reduce that ratio, will also give me 4. So let's start with next is B. So B is the second largest of all the sides. So 12 is going to be in proportion to my Q. So B and Q. So 12 over 3 and 12 divided by 3 is 4. So far, so good. All right, let's see if the last set of sides are in proportion to each other. So actually I want C on top. I gotta stick with the same pattern I developed. So C over R. So my two smaller sides now. So C is 8, R is 2, and 8 divided by 2 is 4. So all three of these sides have the same proportion. So this triangle ABC is 4 times larger than PQR. So remember that this is that scale factor, right? So it tells us how much larger or smaller the triangle is. So this is 4 times larger than the small triangle. So I can say then, because I've shown that all three of these have the same ratio, then I can show that AP over BQ equals over CR, those are all equal to 4. So because these three things are true, therefore, triangle PQR is similar to triangle ABC because of side, side, side. And the last example, given that triangle ABC is similar to angle DC or triangle DCEC, so I don't have to prove anything this time. I know that these triangles are similar to each other. I want to solve for the unknown side measurement by setting up a proportion. So we want to show all of our work. So let's start by labeling our sides. Across from A is little a, B is little b, C is little c. I'll also notice that, hey, there's my unknown right there. So this is what I'm trying to find. I'm trying to find my x. So that's my unknown that I'm trying to find. And then in this smaller triangle, across from C is C, D is D, and E is E. All right, so let's set up our proportions to show which sides are going to be in proportion. So A is in proportion to D. So you have to think about, okay, if I was to flip these, where would they be, right? If I was to visualize, to imagine I'm going to rotate this triangle so it was orientated the same as this one, what would they look like? So A is going to be in the same position as D. B is going to be in the same position as E. And C is going to be in the same position as C. So let's plug in the numbers that I know. So A is 6, D is 4. B, I still don't know what that is, and I don't know, I don't know what E is either. I know that the C from my larger one is X, and I know that the C from my smaller one is 3. So now this is the three proportions that I want to do. And I can only use 2 of my fractions. I can't use all 3 at once. So I'm going to use my first fraction because I know both numbers. And I'm going to use my last fraction because this contains the unknown what I'm trying to find. So I have 6 over 4 is equal to x over 3. So now I'm going to do my cross multiplication. 4 times x is equal to 6 times 3. 6 times 3 is 18. I'm going to divide both sides by 4. Show that the 4's cancel each other out on the left-hand side. We're left with x is equal to 18 divided by 4. It's not a whole number. It's 4.5. And what am I measuring my side lengths in? I'm measuring them in centimeters. So I've used what I know about similar triangles to help me find missing sides. If you have any questions about this lesson, please reach out to me, send me an email, or sign up for a virtual help session, and I will see you in the next lesson.